These are the notes for AP Calculus on the topic of solving differential equations by separation of variables. So when you're solving a differential equation, what you're trying to do is go back from the derivative back to the original equation through integration. And the first thing you have to do is separate the variables. And what you're finding, it's referred to as the particular solution. As opposed to the general solution is where you don't know the c value. But here, because you're given a point on the original function, you're able to solve for the value of the constant c by substituting in the initial condition or the point you're given. All right, let's take a look at excuse me, some different examples here. So here it says find the particular solution y equals f of x. So this tells you it's a function with initial condition 1, negative 2. So that's giving you the point on the function. Original one, 1, negative 2, which we'll use. So the first thing you have to do is separate the variables. So on a one like this, when the derivative is not a fraction, you can just separate the variables by first multiplying both sides by dx to separate the dy from the dx. So the dx is reduced out here, and you're just left with dy equals, on this side we've got y cubed times x minus 2 times dx. Sometimes that's enough to separate the variables, but in this case it's not, because the x is with the dx, that's fine, but the y cubed needs to be with the dy. So the way you separate them after that is just through multiplication or division. So here if we divide both sides by y cubed, that way the y cubes reduce out here. Then instead of writing as dy over y cubed, remember the way to integrate this is to move it up to the numerator and rewrite it with a negative exponent. So this is the same as y to the negative 3 times dy equals, now we're left with x minus 2 times dx. So now the x is with the dx and the y is with the dy, so now the variables are separated. And as soon as they're separated, that's when we can integrate both sides. So using the power rule here, when you integrate y to the negative 3, you get y to the negative 2, and then divided by negative 2 equals, on this side, notice I didn't put the plus c here. You could, but since we're going to solve it for y, you always end up solving these particular solutions for the variable in the numerator. In this case, it's y. It's easier if you put the plus c on the other side. You don't need two different plus c's where they're unknown constants, because you could always just combine them into one unknown constant. So it's usually easier if you put the unknown constant on the side of the variable you're not solving for, in this case the x. So notice here these are just subtracted, so you can integrate each one separately. When you integrate x, the antiderivative is x squared over 2. Just add 1 to the exponent and divide by the exponent. And when you find the antiderivative negative 2, that's just negative 2x. And then we have our unknown constant plus c. Let's simplify it a little bit. Not too much simplify, just this left side you can simplify to be 1 over negative 2y squared. And the right side is about as simple as it's going to get. And then you can substitute in the initial condition to help you solve for the unknown constant. So here's your x coordinate, here's your y coordinate. So you could take those, substitute right in here. For x, there's a couple different places to substitute in, and for y, there's one place. So when you substitute in for the y, it'd be 1 over negative 2, y is negative 2, so negative 2 squared equals, substitute in 1 for the x's, 1 squared over 2 minus 2 times 1 plus c. So notice this gives you negative 2 squared is 4 times negative 2 is negative 8. So we have negative 1/8 on the left side equals That's 1/2 minus 2 is 1/2 minus 4/2 gives you negative 3/2, and then plus c. And then to solve for c, you would just add the 3/2, which when you get a common denominator is like adding, multiply 2 times 4 is 8, 3 times 4 is adding 12/8. So now we know that constant that was previously unknown is negative 1/8 plus 12/8 actually is 11/8. And then once you know what that constant is, you can take that and substitute right back in here before we substitute in our initial condition. And let's see what we've got now. So now we have 1 over negative 2y squared equals, we've got x squared over 2 minus 2x, and then we just figured out c is positive 11/8. All right, so now the last objective is to get this to be a function. You have to isolate the y. Notice the y is on the denominator, it's squared along with the negative 2. So there's different ways to go about it, but I think the easiest way to go from here, first separate the negative 2 from the y squared by multiplying the entire equation by negative 2, both sides. So that'll wipe out the negative 2 here, so at least we'll just have 1 over y squared. Negative 2's cancel out, and then on this side, when you distribute the negative 2, times x squared over 2, the 2's reduce out, so you just end up with negative x squared. Negative 2 times negative 2x is positive 4x. Negative 2 times 11/8 is negative. 2 goes into 8 4 times, so 11/4. Then we need to get the y squared out of the denominator. So you can multiply both sides by y squared. So that way the y squareds reduce out here, and you're just left with 1 equals. Here, though, since we're solving for y, it's not helpful to multiply it out. Just leave it in parentheses, all multiplied by y squared. And then divide by that whole thing in parentheses, negative x squared plus 4x minus 11/4. Now I'll just switch the sides here, so then we'll have y squared equals, I've got 1 divided by negative x squared plus 4x minus 11/4. Then, to get rid of the squared, you would take the square root of both sides, and we'd end up with y equals, and remember when you take the even root of both sides, you first need plus or minus out in front. And the square root of 1 is just 1, so that simplifies to just be 1. But then in the denominator, that doesn't simplify, so we still have the square root of negative x squared plus 4x minus 11/4. And you might think that's our final answer because we have y by itself. That's true, but notice because of the plus or minus, it's not a function, because if we substitute a specific x value, we'll get a positive and negative y value, 2 different y values. And remember, a function for each x, there's one and only one y. So it's got to be either the plus or the minus, and it's easy to tell which one it is just based on your initial condition. Notice we had a negative y coordinate. So that's how we know it's the negative out in front to get a negative y coordinate. If it was a positive y coordinate, we would know it would be the plus. That's how you can tell. In this case, it's a negative y coordinate. The only way that can happen if that's negative, 1 over square root of negative x squared plus 4x minus 11/4. So that is our final answer for the particular solution. All right, let's take a look at a few more. All right, this next one, the derivative starts out as a fraction. So usually what you can do here, here's our initial condition. So this time our initial condition is 2, 0. That's the point on the original function. And you can start out here by cross multiplying to wipe out the fraction. So you get x cubed times dy equals 2y minus 1 times dx. So the nice thing about that is it wiped out the fractions, and sometimes that's all you need to separate the variables. Let's cross multiply. However, in this case, it's a little more challenging because the x is with the dy and the y is with the dx. So they're both end up on the wrong side. So the way to resolve it, again, is using multiplication or division. In this case, division. We can divide both sides by x cubed. And we can divide both sides by 2y minus 1 at the same time to get the x's with the dx and the y's with the dy. So then what we have left on the left side, the x cubes cancel, reduce out. So you have 1 over 2y minus 1 dy equals, you could write 1 over x cubed, but it's easier if you write x to the negative 3 times dx. Now the y's with the dy and the x's with the dx. So now we've got the variable separated, so now we can integrate both sides. But on the left side, it's not yet in the form we can integrate. Here we have to, sometimes you have to use u substitution. So here you would set u equal to the whole denominator, 2y minus 1. But it's a pretty simple one as u substitution goes, because you take the derivative du dy, would just be 2. And then when you solve for dy, multiply both sides by dy, then divide by 2, you get dy is du over 2. So that can substitute in for the dy there. And now we can just write it as 1 over u. And when you put in du over 2, it's easier if you put the du here. And instead of putting over 2, you can just pull the fraction 1/2 out in front. And then when you integrate 1 over u, that's what gives you natural log absolute value of u. And then since it's an indefinite integral, you would substitute the u back in, which is 2y minus 1. And meanwhile on the right side, now that we've integrated the left side, this one you can just integrate just as it is. Add 1 to the exponent, x to the negative 2 over negative 2, and then plus our unknown constant c. And then if you simplify that, that's just 1 over negative 2x squared plus c. Alright, so now we've got integrated both sides after we separated the variables. Now is the time where you use your initial condition again. Substitute 2 and 0 in for x and y. So there's x, there's the y. So I'll have 1/2 natural log absolute value. Y here is 0, so it would be 2 times 0 minus 1. And for x, we'll substitute in 2. So 1 over negative 2 times 2 squared plus c. So that becomes 1/2 natural log absolute value of negative 1 equals negative 1/8. 2 squared is 4 times negative 2 plus c. Just move it up here so we can see it a little better. So now we've got, notice the absolute value changes that to be a positive 1. Otherwise, you couldn't have the natural log of a negative number. So we have 1/2 natural log of 1 equals negative 1/8 plus c. And then remember the natural log of 1 is 0, because that's saying e to what exponent is 0? Is 1, I should say, which is 0. So that 0 wipes out this whole side, so you get 0 equals negative 1/8 plus c. And then you can see if you just add the 1/8, you get c equals positive 1/8. So now we know our previously unknown constant, and we can substitute that in right here. So now we've got 1/2 natural log absolute value of 2y minus 1 equals 1 over negative 2x squared, and we just figured out c is positive 1/8. All right, then from here we're trying to solve for y again. This time it's inside the logarithm. So first we have to isolate the logarithm, and you can do that by multiplying the whole equation by 2 to wipe out the 1/2. And our next step will be easier if we remember natural log is the same as log base e. So we have log base e of the absolute value of 2y minus 1. And then when you multiply this by 2, the 2's reduce out, so we just have negative 1 over x squared. 2 times 1/8, 2 goes into 8 4 times, plus 1/4. And then the way we get the y out of the logarithm to help us solve for it is here you switch it from log form to exponential form. So remember the base here is e, and the logs are equal to exponents. So this whole thing, e to the negative 1 over x squared plus 1/4. Whole side of the equation becomes the exponent of e. And what that has to equal is whatever's inside that logarithm, which in this case is absolute value of 2y minus 1. All right, so now you have to decide, sometimes on these problems an absolute value has an effect, and sometimes it does not have an effect. So the way you tell is look back when you solved for c, when you plugged in a point. In this case, notice we had a natural log of a negative 1. So because of that, the absolute value did have an effect. And when it has an effect, what it does is it essentially multiplies by negative 1. That's how it changes this negative 1 to be a positive 1 right here. So it's just like multiplying this 2y minus 1 times a negative 1. And then this side we still have e negative 1 over x squared plus 1/4. Open the exponent. And then you just have to finish solving for y. So you can distribute the negative. So, oops, we got the equal sign here. So that'd be negative 2y plus 1 equals e negative 1 over x squared plus 1/4. And then the last two steps to solve for y, you would first subtract the 1 and then divide by negative 2. So when you do that, you get e to the negative 1 over x squared plus 1/4 minus 1, and all divided by negative 2. So now we've solved for y. So that is our particular solution. Or the other way, you also could have gone, instead of distributing the negative, you could divide by the negative here, or multiply by the negative 1, put the negative on the e, then you'd end up adding 1 and dividing by 2, and your answer would look almost identical, except it would be a negative e, a positive 1, and a positive 2, where all the terms are the opposite sign, which also would be correct. Now, if the absolute value did not have an effect, let's say it didn't change a negative number to a positive number here, it was already something positive, then you would just basically drop off the absolute value signs as if it didn't do anything. So it'd just be 2y minus 1. So those are two possible things that can happen with those absolute value. All right, let's take a look at one with a trig function in it now. So here again, we've got our derivative as a fraction, so let's try separating the variables by cross multiplying. So when you do that, we get 3y squared dy equals sine of pi x dx. All right, and now this case, unlike the last one, it's a little easier. 3y squared, that's with the dy already. Sine pi x, the x is with the dx. So the variables are already separated, so we can integrate right away here. So we integrate 3y squared. Using the power, we get 3y cubed over 3. And then there's 3's reduced out, so you just end up with y cubed. But on the right side, notice we've got a function side, so we have to use u substitution. So you'd set u equal to pi x, the function inside. And then take the derivative, du dx would be pi. So dx would equal du over pi. There. So that's how we still have the integral. Now you can write it as sine of u, and when you substitute that in, the du over pi for x, the du can go here, and instead of putting over pi, you can pull out the 1 over pi out in front. So then the 1 over pi would stay on the outside. When you integrate sine, you get negative cosine. So it's easier if you pull the negative out in front. And then plus c. But since we use u substitution, we want it back in terms of the original variable, so substitute the pi x back in there. So now I've got y cubed equals negative 1 over pi times the cosine of pi x plus c. And now we integrated both sides. Now we can use our initial condition, which in this case is 3, 2, to help us solve for that constant of c. So those in for x and y. So for y, we've got 2. So that would be 2 cubed equals negative 1 over pi times the cosine. And here we'll put in 3 for pi, so for 3 for x, I should say, so that becomes cosine of 3 pi plus c. So 3 pi, if we draw our little graph over here, unit circle, 3 pi, notice this is pi, and if you add 2 pi to that, go one more time around, 3 pi is in the exact same spot. So it's negative 1, 0. Cosine is x, so that's a negative 1. So if this is negative 1, notice 2 cubed gives you 8. And then that's negative 1 times negative 1 over pi. The negatives cancel out. You just get 1 over pi plus c. And subtract the 1 over pi, so you end up with 8 minus 1 over pi equals c. Alright, so now we know what that constant is. Now we can substitute in right here. So So we've almost got it on this one because it's a little easier than the first two because the y is almost by itself already. We get y cubed equals negative 1 over pi cosine of pi x, and then we just figured out c is 8 minus 1 over pi. And then here, to get the y by itself, the last step would just be to take the cube root of both sides. And remember, with odd roots, unlike even roots, when you take the odd root of both sides, you do not need plus or minus. So that would just be your final answer. Y equals the cube root negative 1 over pi cosine of pi x plus 8 minus 1 over pi. So that would be our particular solution. All right, let's go one last one. So a lot of these separation problems will be abstract problems using x and y, but sometimes you might get some applied problems like this too. So let's see how we do this with an applied problem. This time it says given h equals 16 at time 0. So that's basically telling your initial condition. Height is in inches of the water in a container, and t is the time in minutes. Solve the differential equation dh dt equals negative square root of h over 2 for h as a function of time. So when it says to solve the differential equation, again, we're solving for the variable in the numerator h, and it even tells you that right here for h as a function of t. So again, we can cross multiply here. Now notice on this one, we've got a negative out in front of this. So when I'm cross multiplying, I got to choose where I'm going to put the negative. I can put it with the square root of h, or I can put it with the 2. Either way is fine. I'm just going to put it with the 2. So when I separate them, I will get negative 2 times dh equals square root of h times dt. But this time, unlike the last one, they're not separate. Notice there's no t's other than dt, so you don't have to worry about getting those on the right side. However, the square root of h is on the wrong side. It needs to be with the dh, so we divide both sides by square root of h to separate the variables. So let's try to write the left side so it's easier to integrate. We don't want the radical in there, and we don't want it on the denominator, so it'd be negative 2. And when you move that up, that'd be h to the negative 1/2 times dh. And notice all that's left on the right side is just dt. So h is with dh. If there were any t's, they'd have to be with dt, but there aren't any, so they are separated right now. So you can integrate both sides. So the negative 2 just stays out in front as a coefficient. And then when you integrate h to the negative 1/2, you add 1 to the exponent, h to the 1/2. And then dividing by 1/2 is the same as multiplying by 2. And then since we're solving for h, I'll put the plus c on the other side. Now on this side, when you're integrating, remember in front of the dt is a 1. So when you integrate that, you get 1t, or just t, because the variable is t. If the t wasn't there, we wouldn't know what variable to use, and then plus c. So if we simplify this a little bit, so it's easier to work with, negative 2 times 2, that'd be negative 4. H to the 1/2, that's the square root of h, equals t plus c. All right, so now we can use our initial condition. It's just written a little differently. Notice they tell you right here, h equals 16 at time 2. So you can put those in for h and t. So negative 4 square root of 16 equals t is 0 plus c. So c would equal, square root of 16 is 4 times negative 4 gives you negative 16. Let's substitute that right in here. And then we've got negative 4 square root of h equals t, and then we just figured out c is negative 16. And then divide by, we want to solve it for h, remember the variable in the numerator. Divide both sides by negative 4. So you get the square root of h equals t minus 16 over negative 4. And then last step, square both sides to get rid of the square root. So you get h equals, and let's just make it a little simpler. So t minus 16, that's probably not going to make it simpler to square that, so I'm just going to leave it t minus 16 squared. But the negative 4 is easy to square. Negative 4 squared is just 16. So that would be your particular solution function for h is a function of time. So now this one actually has a practical application as opposed to the first three, which are more abstract ones. So now if it asks you, let's say, at what time does the container have no water in it? Well, if there's no water in it, the height is 0. So you would set 0, plug in 0 for h. And notice if you set the numerator equal to 0, you can see that'd be 16. So it'd be at t equals 16 minutes would be when the container is empty. All right, and that concludes the notes for AP Calculus on the topic of solving differential equations by separation of variables.